Okay, this is lecture 2 of week 8, which is supposed to be on July 5th. Now, I want to remind you that I will be away for 4 lectures starting today, and this is why these are recorded earlier and posted on YouTube. Also, there are 2 presentations for the labs that are also going to be the 1 hour presentation at the beginning of the lab are also going to be recorded and posted on YouTube. Now, the problem that we're going to do today is something called a slider crank mechanism. And after I do that, I want to show you how to generate, once again, put the physics into the problem, generate the trace, and also generate some plots, which can be submitted as part of your if asked on the final exam problem. Okay. So here's the situation. We have a slider crank mechanism, which is a simplified version of a single cylinder engine. So it's made of a base. That's where the piston or block is going to be traveling. There is a crank that goes into this hole and starts turning. And there's a connecting rod that connects the crank to the block. And the block goes up and down the base. Initially, I'm going to make only cartoon, basically, an animation. And then I'm going to come back create some physics behind it. Now, keep in mind that the only 2 things that are important dimension-wise here is the length of the connecting rod and the length of the crank, okay? Everything else is totally irrelevant to the problem as a kinematics of the mechanism, okay? So all I'm going to do is to make sure that roughly this is about 6.5 inches and this is about 3.5 inches, okay? Not critical. All right, let's go here. Let's go here and start the product file. So we're gonna go to new product. Okay, and immediately we're gonna save this. So we go file, file, save management, save as. On the desktop. On the desktop, I need create a new folder, and I'll call it slider crank. Slider crank. And this is on July 5, right? July 5. Excellent. So we say OK and save. All right, we're going to close this. I'm going to insert my first part, which is going to be the base. I start making the base or that track first. So insert a new part in there, and I will call this. Let's see now. Right-click properties. The part name or part number is base, and the instance name also I use same as the name. Okay, let's make it. Double click on the base. That puts you in the part design, and it's a very simple geometry. So on a convenient plane, on that vertical plane, I will sketch something that's about maybe 20 inches long. That's going to be basically your track. Let's have an idea how big this thing is roughly. Well, actually it's 12, so yeah, let me make it 15. Good. Okay, so let me move this thing a little bit here. And on this end, I'm going to make a circle. And this circle eventually is going to be that pin that's sticking out, okay? So exit. Now, if I pad this thing, I will get a hole here. Now, I don't want to get a hole, so I can do a multi-pad. That tells you that there are three curves here, closed curve. This is the rectangle. So let me pad this thing by 1 inch. I don't know if it looks like that. And this is the circle here. If the thickness is 0, you're going to get a hole. But if I give it a thickness, for example, I don't know, 1 maybe. Oops, wait a minute, not 1. Maybe one and a half, right? Because the other one was 1. That's why you can't see this So I'll make it 1.5 there. Okay, good. So this is done. Now I'm going to make the crank. The crank looks like that. Something which is about 3.5 inches center to center and two holes. Okay. So insert a new part. Always say no. Right click, properties, and I'll say crank and say okay. Double click on the crank to make it. Okay, so on a convenient plane, on that plane, I will sketch. Okay, why don't I project that circle on it instead of making the circle and dimensioning, etc. So the normal view is here, and I'm going to construct a crank. So let's see now. We're going to make something like this. We can dimension it later on if needed, and clean it up again if needed. Okay, that's good. It is possible that if you want, you can make these two concentric. As a matter of fact, let me do that. So this circle, control that circle. It just makes it look better. I'm going to make it concentric. Okay, good. All right. And this control that, I'm going to make it tangent. You know, likelihood it is tangent, but if not, yeah, okay. So there is going to be a whole circle on this end, which we're going to pad this and makes it a hole. So exit and pad it by, I know that this is 1/2 inch, so I'm going to make it 1/2 inch. Pad it by 1/2 inch, 0.5, so that it becomes flush to this. Okay, good. Now we're going to insert, oh, by the way, let's save everything first before we lose things in the event of a power outage or something like that. Or in case I have to shut down Katia. Okay, so on a insert, the next part, connecting rod, new part, say no. I'll call it Conrad. Properties, call it Conrad. And Conrad. All right, let's make it. Double click on it. You go into part design, it's a single gear. So on a convenient plane, perhaps on this plane, I will sketch. All right, so first of all, let's project that circle because I want to have a pin here. See that? So project that circle. Good. A normal view. And let's do the rest of the connecting rod. Anything that's blocking your view and is bothering you, you can obviously hide, but it's okay with me. So let's see now. We do, here's going to be our connecting rod. Oops, I wanted to make this thing a circle, but I missed the opportunity to do that. So I'm going to click on that guy. It turns it into a circle. Okay, so let's see now. And we can clean this up later on. Good. Okay, so actually I wanted to make this thing longer, and I can because there are no constraints here. We can just drag it. Very good. Okay, and then we clean it up. First of all, I want this circle, control that circle to be concentric with each other. Good. I think that takes care of everything here. And then another circle at this end. That's that is the hole that is going to go into this pin of the block that we will make in a minute. Now, if I exit and if I pad this thing, I'm going to get holes at both ends. But I want a pin at this end and a hole at that end. So let's see now. We're going to do multi-pad. At the end of the day, you have to make these parts any way you know. If you don't know multi-pad, do it a different way. So this is that extremity. So let me make this thing perhaps maybe 0.5. Okay. And that one is the circle at this end, at the right end, which I wanted to remain a hole, which I'm going to make thickness 0. But this is at the other end, and I want this thing to be a pin, basically. So I'm going to make it, already that piece is 0.5. I add another 0.5 to it to make it 1. So we go 1, and there we are. Now, it is true that I have to turn this thing around and stick it in that hole, but anyway, for now, it's okay. Now, let's go ahead and to the product and make sure you save everything. And now we're going to do the block. So we go with insert a new part. Always say no. We come here, right click properties. The part name is block, which is our piston essentially, and instance name also block. Good. Now let's go make it. So double click on the block. That'll put us in part design. On a convenient plane, this is convenient to me. I'm going to sketch or maybe, I'm not sure. So it really doesn't matter. Okay, that's fine. Sketch, project that circle. Okay, normal view. Let's do the rest of the block. So I'm just going to make a rectangle here. Okay, and because I want this thing to be a pin and this thing to be a pad, so I can do a multi-pad. Exit. Now, remember, once again, you have to create these parts the way they are any way that you know. If you don't like this, no problem. Do it your own way. Now, this thing is, I made it, I believe, 1. So I'm going to make that thing 1. You can see that. And this thing, I want it to be 0.5 inch here, 0.5 inch here. I'm also going to make it 1, but that 1 plus 1 is 2. So we make this thing 2. And there we are. Okay. Very good. So let's go all the way to the top, all the way to the top. Double click, save this thing. And now we're going to do assembly design to make it look the way we want it. First of all, let's anchor the base. So here's the anchor the base, because I'm going to be using the magic wand to automatically create the joint. By the way, let's move these things apart so that we can see what we're doing here. So let me translate everything in the Y direction. Let's translate. Yeah. Y direction, okay, and this is also the Y direction. There are no constraints here, and just to convince you, I'm going to also translate this thing in X, etc. Good. Okay, first of all, let's insert this pin in that hole. So coincidence between the axis of this and the axis of that, and update. Okay, and then coincidence between this face and that face. Update. Good. Now, just so that things look better, I'm going to rotate this. So I use the move manipulate icon. Rotate. This is free rotation. This is free rotation. The rotation about X, about Y, and about Z. This is free rotation about any axis that you pick. Select this axis, and then make sure that with respect to the constraint box is checked, so that when I move this thing, this doesn't come off like that. Okay, good. So now we're going to say coincidence between this hole and that pin, and coincidence between this face and that face. And if the thing doesn't look the way we want it, we flip these arrows or we change same to the opposite. So let's find out. Yeah, you see, that's not what I wanted. So although as far as the mechanism is concerned, it doesn't care. The kinematics is the same, but I'm going to flip these and update, and it looks a lot better. Okay, good. Now let's put this block on that base. So coincidence between this face and this face, update, and coincidence between this edge and that edge, update, and finally put this pin inside of that hole. Coincidence between this axis and that axis. Notice that all I'm doing is axis to axis, and that means this is not going to be revolute. These two are going to be revolute joints, but this one is going to be cylindrical, and that guy block on the base is going to be prismatic. Let me update. Good. So actually our model has been created. Before we lose it, we're going to save everything. We are in assembly design. Click on the floppy. Okay, now, how do we know if things are almost right? So I'm going to do the move toolbar under manipulate. I'm going to do free rotation with this box check about this axis. And now I'm going to rotate, sorry, rotate, okay, about that axis, and I'm going to rotate. You see, this is working the way it's supposed to. All the constraints are the way I want it to, okay? So we say, all right, that's good news. And yep, now we're going to go to digital mockup, DMU kinematics, and we're going to use the magic wand to create the joints automatically. Oops, this was the wrong place. Try it again. Digital mockup, DMU kinematics, the third one. Okay, now notice that there is a magic wand here. We can try to convert all the joints to all the constraint to joints, and it happens in simple cases. There are cases that magic wand is not going to do you any good. Okay, you click on it. It says it's a new mechanism. What do you want to call it? Mechanism one is fine, and then automatically create here. Automatically create the joints. So what we're going to have is it's going to be. Let me close these things. Don't need it anymore. Okay. There's going to be two revolute. Degree of freedom is 1. That's because the position of the crank will tell you exactly where these things are. Degree of freedom is 1. And there's going to be 2 revolute, 1 cylindrical, and 1 prismatic. Prismatic, revolute, cylindrical, prismatic. And the nice thing about giving instances the proper name is that it tells you what these joints are between. Okay? So, all right, let's do this joint angle driven. The crank one angle driven. So crank and the base right here. Double click on it. Angle driven between 0 and 360. Okay, so let me just move it. Obviously, so mechanism can be simulated. That's good news. And this is the manual simulation with command. In other words, you're in charge. If you drag this thing, this will go the way it's supposed to. This is just the animation, no physics. If you want to make it automatically, just go and create a simulation. There we are. And create a simulation. Just cancel. Sorry, I missed something. Click on it. I forgot to select my mechanism. Mechanism 1. And now you're going to get two of these. Okay. I got one, so I knew that I forgot to do something. Now drag this all the way to the end. Don't fool around with it. Insert, rewind, and play it with anything but 1. 1 means that jumps from one end to the other end. So let's say 0.4. It really doesn't matter. And we're going to play it continuously. Remember, this is for being in a loop. No physics, just cartoon. Good. So, okay. Now, a couple of things. I want to find the trace of the center point of this connecting rod. So let me go back to that connecting rod. All I did was double click on it so that in part design and in the connecting rod. And I'm going to create a point. I'm going to create a point on the connecting rod, on the surface of the connecting rod, on the surface of the connecting rod. So maybe the surface, yeah, this blue point is good. This blue point. You say, okay. All right, so I created a point on this connecting rod. Now, let's go back to our mechanism. I'm double clicking on this so that I go back to mechanism. Now, in order to find the trace, first you have to compile. You already created a simulation. That was the first step, to compile. So you go back to the compile, and all I need is a replay. I don't need a video clip or anything. So this is fine, generate replay. Don't use one, use anything but one, and just say, okay. This compiles it and will allow you to plot the trace. You say, okay. Now here, once you create a replay, you can go and create a trace. See that? Magnifying glass, footprint, trace. And it says, okay, element to trace out, it's this point. And reference product is actually product one right there. And 26 point, this is the number of points, but I tried to change this thing. I didn't take it. I'm not sure why, but anyway, it'll do it with 26. Probably you can reset this thing somewhere. I'm not sure where at this point. We say, okay, we'll wait, and the trace will be created right there. Okay, now, this trace is created, but it has to be saved because it could be on the final exam. I asked you to create the trace and also bring it into the mechanism. So here we go to File, Save Management. Notice that everything is saved except for this trace. Say Trace, Save As. In that same folder, sliding July 8, that's not the one. It was slider crank mechanism, July 5, right? Let's see if we can find it here. Oh, slider crank, July 5. And I'm going to call it trace 1. I'm going to put it there. And we say, okay. So the following that will not be saved. Yeah, okay, because those were already saved. No problem. The trace is going to be saved there. So if I close this and I say, by the way, I can check. If I go to my uh, slider crank mechanism, July 5th, you see the trace was saved right there. Okay, so let's go. If I want to bring it in here, you say insert, existing component, not a new one. And it says, where do you want to put it? I want to put it in this product. And it says, where is it? It's slider crank July 5, trace, and I bring it in here. Excellent. So if you do the replay, you see that actually, let me make this continuous. That point is going to go through this path. Okay, good. I will ask you to do the trace on the final exam. I can guarantee you that. Now, this is all a cartoon. So we're going to put some physics into it. Suppose that this thing turns at 60 RPM. 60 RPM is 1 round per second, and 1 round per second is 360 degrees per second. So let's go ahead there. And we're going to go to f of x, knowledge toolbar, f of x formula, remember? Good. If you click on the mechanism, only the stuff related to the mechanism is going to pop up. Let's try this. Only the stuff related to the mechanism. So this is the angle of the crank. Add a formula. And we said that the angle of crank is its speed times time. So 360 DEG divided by 1 second, times time. So the time variable is in the second column. Double click on this. It puts it right there. The units must match. Angle in degrees equal to something in degrees on the right hand side. If there is any issue, you're going to get a syntax error or something is not right, etc. But this is fine. So now there is some physics into the problem. So we can do simulation with law. By the way, this appears in the mechanism as a law, right there. You see that? The formula that you inputted is right there. If you want to change it, by the way, you double click on it and then you go and change it, but I don't want to do that. Okay, so we're going to do simulation with commands. Where is that? I'm sorry, not simulation with command. Simulation with laws. Simulation with laws. Simulation with command is what you do yourself manually. Now, I don't want it to do 10 seconds because that's going to go 10 times. So I'm going to do it 2 seconds. How about that? 2 seconds. You can set the time there. Good. Now, I want to, first of all, you can run this thing, but you're not going to be able to verify anything because it just shows you that as if it was a cartoon. So what we're going to do is we're going to try, for example, to plot velocity of this point as a function of time and velocity of this point as a function of the crank angle, for example. Okay, so let's go ahead and do this. The first thing, before I do this, I close it. I'm going to go and create a sensor. So there is a sensor, a ball rolling down a hill. Click on it. Okay, it says, all right, what is the reference point? The reference product is that, of course, the base. And what is the point? The point is this point. This point. You see that? This point. I want to get some information about this point. We say, okay. Now we go simulation with laws. I already changed it to 2 seconds. I go to activate sensor. So I'm going to do two things. I want to get, first of all, the plot of velocity of this point as a function of time. Okay? So I say, okay, give me velocity of this. This is remember, this has only x velocity, x direction velocity. So y direction and z direction are 0. So it doesn't matter whether you ask for x linear speed or linear speed. They're going to be the same thing. This is the x component of the velocity of this point, but since this point moves only in the x direction, you can also ask for linear speed. The difference is that x linear speed can be positive or negative, but linear speed is the magnitude of this, and it's always going to be positive. So I'll use x linear speed. How about that? Okay. Now, so notice that the no here changed to yes. Now, also, let us do, for example, if you want, for example, if we wanted, for example, the position, the angular position of the crank versus time, I also just do this as yes. We change it from no to yes. Now, don't close this. Just move this thing down. Just move it down and play it. Wait until it goes twice. It will go twice. By the way, I didn't need the trace to do this. Trace was just something that I was interested in. And I say graphics. Two curves are going to be created. One of them is, well, first of all, we can zoom in and out of that. No problem here. And I can change the spacing here. I have two things. What is this? Let me see. I can't see what I did. It says this one is the angular position, and as a function of time, cylindrical 3. I don't, well, let me see for a second. This is the speed. This is the speed. You can see that the green one. So it's going to be inch per second versus time. That's what we wanted, positive and negative, because I asked for x linear speed. Now this one I don't think is what I wanted. So let me close this. Let me close this. See what I asked for. Rewind. First of all, rewind. Clear the history. Clear the history tab. Clear the history. Let's do selection again. What did I select? I wanted this guy. This is the thing that I wanted. not the other guy. I didn't want the other guy. For some reason, I wanted to pick this. I want the revolute angle, and I made a yes. Okay. So this and the x linear speed. Once again, run it and wait until it finishes going around twice, and then you click on the graphics. Right. So this yellow line is actually the revolute angle. The angle increases linear as a function of time. But I forgot to uncheck this cylindrical one. So let's do it one more time. Go back here, rewind, clear the history. On the selection, there are three things that I checked out. I want two of them. The revolute, this is the one that I inadvertently had said yes. I click on it, it says no. Once again, play. And when it reaches the end, graphics. There's going to be two curves there. This is the x component of linear velocity of that corner point, and this is the angle of the crank as a function of time. Now, if these are the two graphs that I asked you to do for the final exam, what you need to do is you have to do a print screen, okay? Print screen, go to maybe a Word file or something, and paste it. Oops. Let's go back here. Print screen. Where is the print screen? Print screen. Go to the Word file, paste. There we are, and save it. File, save as. Let's go slider crank. It was here. I could have selected it from there too. Slider crank. Where is it? Slider crank, July 5. My plot, let's say plot of x linear velocity and angle of the crank, of course, versus time. Okay? And it's going to go into that folder. So let's check. Minimize, minimize, slider crank, right here. Plot of x linear velocity and angle versus time. Okay, good. Now I want to get something else. This is done. I'm going to done with this curve. Rewind, clear history, selection. Now I want to go and plot, for example, x linear velocity, not versus time, but versus the crank angle. So I go under options here, under a customized plot, and I say add. It says, what do you want against what? So for example, I want abscissa is, I believe, abscissa is y, I think. So this is going to be x linear speed. X linear speed. Now remember, you must have asked for these in order to be able to create these customized plots. And this one is angle, right? Revolute angle. As a matter of fact, I think these are backwards. So x linear angle goes here. That's x. And this is going to be x linear speed. It's just that otherwise it's 90 degrees rotated. So we say okay. So we created the curve one and rewound. Let's play it. Don't close any of these, okay? Just can move it out of the way, but don't close it. You have to close this, okay? Play it. And then once it reaches the end, you say graphics. So something I did not ask for. I bet one of these things that I selected there was not asked for. So let's go. Let's rewind this. It's good to make these mistakes and go clear it up. So let's go here under options. Let's edit this curve to edit. Let's see what we did. Angle. Oh, linear acceleration. No, it was a speed. X linear speed. Okay, good. Close that. Play. I'm glad that I'm making these mistakes because you're going to be making it too. And at least you see how to fix it. And finally, graphics. And there we are. So notice that this is not versus time anymore. It's, let's zoom out. This is linear speed versus angle. It just happens that it looks as if it's versus time. Very similar because actually the angle is a linear function of time. Now, once again, if I asked you to generate a graph like that, you say print screen, go to a Word document, paste, save as, file, save as, this folder, slider crank, I think it was this, right? Slider crank July 5, yeah. And we say, give it a name. So it's X linear speed versus crank angle. I just want to remind you that you will have problems like this on the final exam to generate these things. And anyway, let's do a quick save here. And we just get rid of this. Everything is good. And that is the end of this particular lecture.